In the previous demo, we used some visualization software to see what sounds that we hear every day look like. And in this demo, we're going to use a computer to generate more complicated sounds from simpler notes. And again, we're looking at the different properties of amplitude and frequency and how they come into sound waves. So we've opened up MATLAB, and now we're going to open up the harmonics.m file, where the demo is located, and then we're going to hit run. Okay, so this window shows some things that are similar to the visualization demo. On the bottom, we have a plot that shows what the sound would look like if we could see it moving through the air. And then on the top, we have a plot that shows the note that we're playing. So in this case, we have this one note, and this is what its waveform looks like. So if we play this sound, it sounds like that. Okay, so that's a relatively low note. We're going to play a higher note by clicking over here. When we go to the right, we get higher notes. And if we remove this note, you can see that the frequency of the sound wave increased. So the peaks got closer and closer together. And then if we listen to this sound, it's going to be significantly higher than the first one. Right, so it's a much higher sound. Okay, so now if we click, we add more notes in, we'll get a more complicated both sound wave, and then when we listen to it, it'll sound more complicated. So as you can see, as we add more and more notes, the shape of the waveform gets more complex. And we can see how it changes. And then if we play the sound, we hear a sound that sounds more complex. In some ways, it still sounds like one note, but you can hear the different frequencies coming in at different points. There should be like a high ringing sound and then also some lower notes. Okay, so we see that as we add more notes, we get more complicated sounds, and we can build up complex sounds by adding more notes together. Okay, so now we're going to show a couple more complicated sounds that we can make. The first one is called a triangle wave. And so you can see the shape of this wave looks like a triangle. And these are the notes that we have to add together to make up this wave. And so as you can see, it's fairly similar to the original wave that we started out with. We just add a couple small notes in here to get this triangle wave shape. And so when we play it, it's going to sound similar to just the basic wave that we played at the beginning. But if you listen really closely, you can hear the small ringing frequencies also. Okay, so now we're going to play a different wave called a sawtooth wave. And you can see this one is more complicated. We need to add more notes to get the shape. And so it's going to sound more different from the basic sound than the triangle wave did. You can see it's a much harsher sound. Okay, now we're going to play an even harsher sound called a square wave. And you can see it gets its name because the waveform takes this kind of box shape. And if we play this sound, it's going to sound even more harsh. We can hear the higher notes ringing at the top. Okay, so now we're going to try a couple musical instruments. So we have a flute sound. And this one's closer to the basic sound that we played, but it's you can see that there's this couple extra notes right here. So if we play that, it sounds like a flute. And now we're going to play a trumpet sound. In the trumpet, we have a bunch of extra notes added in to get the sort of characteristic trumpet sound. And again, you can see it's obviously a more complicated sound than the simple sound that we played at the beginning. So in this demo, again, we've looked at the concept of frequency and how higher notes have a higher frequency. And then we've also seen, again, that when you take simple notes and add them together, you can get more complex sounds.